Hi, my name is Dave Wu, and I'll be hosting this podcast series on water treatment solutions. This podcast series will cover water treatment using membrane filtration. Today's segment is dedicated to water reuse. What's water reuse, you may ask? Well, water reuse is treating water from municipal, produced industrial, or agricultural sources prior to releasing it back into the natural environment. Or in some cases, the water is reused in industrial or agricultural production. Well, joining me today is Stanton Smith.
Hey, Dave.
Hey. Stanton is the Senior Vice President of Sales and Marketing, and he's also one of the three co-founders at CrossTek Membrane Technologies. Stanton is a 20-plus year veteran of the water industry. He's worked at companies such as Veolia, Water Technology, Nanostone, and Ceramem. And get this, he holds a PhD in chemical engineering from Oxford, all the way Oxford.
No. Everyone's giggling when they hear that.
Yeah, well, I always love the thing that you're a Rhodes Scholar too. That's
I do drive those trucks well.
Rhodes Scholar. That's pretty impressive. So anyway, welcome, Stanton.
Thank you very much, Dave. Thanks for that.
Yeah. So Stan, I was wondering, tell me about CrossTek. Why did you guys, what do you guys do? And why did you start CrossTek with Bruce Bishop and Job?
Yeah. So I'd say this, I was the late part of the founding team. I joined a little later, but I always have had common ground with Job and Bruce, and that we really think that, technologies should be used for treating water. It's the most important thing we do is make water for drinking, for society use, for protecting the environment. Ultimately, CrossTek's entire mission is doing membranes and water. It's pretty simple. However, when you think about what's out there in the space of companies, there are thousands of companies out there doing water treatment. What's our edge? What did we bring? Why was this company formed? And that real focus of our company is membrane technology, but also next generation, bringing it to the market, the hard stuff, the stuff that people don't want to do, quite frankly. We pick up the heavy lift of looking at the market needs, looking at the trends as best we can. We don't have a crystal ball, but we see these trends, these needs that not for next year or the year after, but the next decade or two. What are those trends? And we think membranes can fulfill that need, fill that gap. So we try to be a market-focused company, bringing water filtration technology that leaps the current state of the art. That's the mission. The mission is to be looking to the future and solving those problems, not just for now, but for, and not to be cheesy about it, but the next generation also thinking about the future of our children. CrossTek is really focused on that.
That sounds great. I know you actually said a couple things that piqued my interest, and I'm sure we'll get through them. Some of them is the next generation of technology. I know that you and two of the other founders, Bruce Bishop and Job, you recently published a paper for the AMPTA membrane conference. Was wondering if that's something you can talk about.
Yeah.
What was the paper about, and who was the customer, and what were some of the considerations that you talked about in that paper?
So this paper is I hope those who attend the show come and see this one, because I like this paper in particular because it shows a few years of experience, not just design and sale but actually real experiences, things that didn't work out as we thought, things that changed as we operated, and stuff like that. So, due to confidentiality of the customer, I can say that they are a major engine manufacturer, and they you probably know them. They have a good CSR policy, and they really want to do the right thing. Okay, so that's the company. I would say, first thing I'd say is corporate responsibility initiated this project, period. There was no other reason for this. This is a company that basically had to add in multi-million dollars of equipment to do the right thing and add stuff to go with it in an environment where there's more water than they know what to do with, to buy it at low cost. So that was the driver. The project itself is about as full-fledged as you get. I can't imagine. I think I might have called it lead to gold in some LinkedIn post I did the other day to promote it a little. But yeah, it's literally the worst water that you could possibly think of in a membrane filtration system.
So the water was, what was they were trying to treat the water that was a result of the manufacturing process.
Yeah. So I'll tell you what the water is. This is massive engine blocks being machined from flat steel to shaped steel. And to do that, it's real intensive spray of a combination of water and oil on the surface of the metal while the machining happens. CNC machining, we've all seen it. You spray lubricant and coolant combined, which is water and oil, onto this machine, and they just make hundreds a day, hundreds of these engine components every day. And then they do dye penetration testing and various testing, and all of those wastewaters come in as well. But this is water that looks like a milk, creamy emulsion, not a very drinkable milk, but it looks like a perfectly mixed water and oil combination that is intractable. If you set it down for 5 days, it would look exactly the same. There's no oil floating. It's intractable, oil and water. We call it a stable, chemically stabilized emulsion for all intents and purposes. Not many membranes can treat that, so what we did was we put that in. So that's basically 50% of the water that we treat. The other 50% is the 2,000 or so staff members that work there, canteen activities, just human waste coming in. They call that sanitary waste. I always laugh about that. The industrial guys call that sanitary waste. That tells you what their real industrial waste looks like. So we got the sort of engine block stuff, and then we got the sanitary waste. And they segregate those because they need different treatments. And so this particular facility takes this really hardcore engine oil, and they came to us and said, let me not take credit for everything here. CrossTek is amazing. Yes, we are. But these guys always used ultrafiltration to treat that since the 70s. Unbelievable. Maybe 80s, 70s, 80s. We walked in there and we just saw this, clearly 80s technology. There was a beautiful, literally 5 foot tall by 10 foot wide control box with light switches on it, with relays switching controls. It was like a museum to control. But they used ultrafiltration, but they needed to do more with less space, because now they were going to add in a whole lot of reuse equipment into what was just a discharge plant before. And so, CrossTek basically came in, took that industrial waste, applied ceramic cross-flow membranes to treat it into a oil-free, and I should say emulsion-free solution that was then ready to go to biological treatment. So it goes from there to biological treatment to consume remember the ceramic ultrafiltration removes particles and oil. What's left is dissolved material that's biodegradable. And so the biodegradable part was then mixed with the sanitary waste. Remember what we call sanitary waste? It blended together and fed to a membrane bioreactor. So another membrane plant, which was designed to, keep bugs in a good concentration. And then the effluent from the bioreactor then goes to a reverse osmosis plant for 90% water recovery. And that 90% permeate goes back to 2 major applications. Cooling tower for cooling the facility, the production facilities. All the machining needs cooling. And to boiler feed water to produce power, to produce steam around the plant for production activities.
So I think what I heard you say is their existing ultrafiltration, which they've been using since the 1970s, and maybe explain, what was it missing? Was it just it was not properly breaking down the oils? And so I guess my real question is, you talked about this old technology using, or old configuration, I should say. They have this ultrafiltration, and what did CrossTek come in your paper? What did you add?
Yeah, good question. That technology was cutting edge in the 70s and 80s, and if you don't mind indulging me, we can speak about this for 1 second. CrossTek CEO Bruce Bishop, many years ago, started working in a company called Ceramem. Ceramem's founder, now here we go back another generation, was the first employee of a company called Abcor. And Abcor, in the 70s and 60s, invented this tubular UF concept. 60s. So The CEO of CrossTek was the first employee, I think, for Ceramem, but the founder of Ceramem was the first employee for Abcor. And those tubes were the bee's knees in the 60s. No one could do what those things do. They were amazing ultrafiltration membranes, and believe it or not, they're still in use, but the problem with those was walking into the engine facility was that they were just huge, just unbelievably huge. A lot of what we're doing now has to address more than the beautiful science. It's got to address retrofit. It's got to address existing facilities, especially in the US. People don't like to break out concrete walls to do stuff anymore. If our reuse project had another building that had to be built, they might have killed it right there. So instead of doing that, we saved about 60% of the area, floor space, for that wastewater building by changing technologies. Same concept, ultrafiltration, same even process configuration, cross-flow. But we went to something that was, 50 feet by 30 feet to something that's a quarter of that. Now you freed up enough space to do the other water treatment that enables you to do reuse in that same floor space. So that was a major step for that. And that's one piece. The second piece, no building means lots of savings, right? The second thing is we were more reliable. Products, materials have changed. You went from a polymeric membrane to a ceramic membrane. Ceramic membranes in their very nature are hydrophilic. Hydrophilic being oil hating, water loving, and so that emulsion would routinely clog up those tubular polymeric membranes, and the cleaning frequencies were pretty high. Okay, on a production site like this with over 50, 60 different production trains spitting water out at any one time to the wastewater plant, you got to be nimble. Ceramics are robust, they're cleanable. They offer an improved materials almost optimal for oil emulsion treatment. So it's a combination of retrofit, right, and materials and configuration change that really moved that forward.
So what were some of the key challenges at this engine manufacturing plant as they were considering upgrading their equipment?
Yeah, Dave. So I said this. That would have been started in 2015 when this discussion started with the customer. They had two things happening at the same time. One is they were formulating their corporate social responsibility goals, and they said, we got to achieve these certain water reduction requirements. So that was part of the driver for this. The second driver was that this plant was built, in the 70s and had a wastewater plant which was dating to that time. And their wastewater plant at that time had simply two pieces to it. It had treated the industrial wastewater with an ultrafiltration system, circa 60s technology, and then also had a post-ultrafiltration system to treat the dissolved organics in the ultrafiltration filtrate as well as the sanitary waste on site. That was made simply for discharge to the local publicly owned treatment works. So here we have a plant that's already in existence for 40 years, and they do discharge to the local city, and they want to take that and create a brand new recycle plant because they've now decided that they need to do better and more for the community by reusing water. So all that said, now you've got to think about all the million things that go into that. You have this building, a wastewater building, with a limited footprint. When we walked in there, we couldn't believe it. This beautiful 1960s technology took up half the building, right? But it was ultrafiltration, and it had a bunch of problems associated with it. It was old, it was aging, it was operating intensive. It was made of polymeric membranes, which was the only choice in the 60s and 70s for treating this kind of wastewater with emulsions. But the time has arrived pretty much 20 years already. By that time, ceramic membranes have been used. So, it was ripe for change. It solved two problems by doing that. We could engineer a system which is much, much smaller. So now you freed up footprint for installing additional equipment for reuse inside the existing building, saving a lot of money and just time to achieve your goals, construction cost and construction time. So we hit that goal there. So you're hitting sort of the key things we were talking about earlier. You're talking about existing infrastructure retrofit. You're hitting improved performance and better materials. You're hitting sort of operator intensity reduction. So you kind of look at those goals and they come right out when you apply the right technologies. I should state that the incumbent membrane product was still a strong company and still in existence. And they were part of the evaluation. So what was in their favor? They've done it for 30 years with that thing. They know the enemy they're facing. The new technology to them was new, ceramic membranes, had to be proven.
So you mentioned several things. One was the existing footprint. It's not like they're going to build a new building or expand things. So big advantage to fit into the existing space.
Yeah.
But in that existing space, the new technologies, from what you're telling me, smaller footprint, allowed you to add in new configurations, which made the whole system much more efficient.
That's right.
And materials
underpinnings of success of this project was the ceramic material.
Ceramics.
Yeah.
So it was all about ceramics against polymeric. And that's I assume that's actually...
That's a theme in our day-to-day living in CrossTek, right?
And is that what's going to be presented in the paper? You're going to be discussing those?
We're going to be discussing those, and I'm pretty sure that there'll be lots of questions because that is the dilemma or the question of the day. So here's the funny thing. Everyone loves ceramics when they hear the technical aspects. Right, I remember presenting ceramic membrane solutions in the early 2000s to people saying, this is perfect, look at the performance, we got an installation somewhere, and they just look at me and they go, well, what's the price? Because back then, they were so expensive, they had nothing in their favor, no scale, no adoption, no real broad-based supply chain. And now, it's different. We got volume on many of these supply chains, we got better pricing. They were never questioned technically. They were just like, oh, well, we might as well make it out of gold then.
So the prices come down.
The prices come down.
And that's, in a way, you're saying that's why now is the time.
It's the time.
It's the time because
and I
the
think
prices
people will
come
see
down.
the value is right. This particular project was nice indication on that front end on the UF portion because it was UF to UF. I felt it was an unfair evaluation because they didn't give us the building savings.
True.
But they said, well, let's just keep merit to merit, they called it. I'm like, wait a minute, we saved you a building. Anyway, it was still, so what happened was the ceramic membrane was capital 20% more capital, but the life cycle saving over 20 years was 30%, including the high capital. And the operational intensity was a fraction. It had better warranties because it's pretty easy to warranty ceramics now because the conditions of operation. These things are baked to 2000 Celsius, okay? You're not going to wreck them with anything you're doing in water and wastewater. So a lot of it was giving them comfort. The demonstration, we performed a 1-month demonstration on site with a small version of the technology, showed them the power, the membrane capabilities to perform as well or better. So a lot of that demonstration occurred on site. A lot of it was to give the site comfort because it's hard to turn away from something you've done for 20 to 30 years. And so we understood that and we did that. And no matter what people say, you never make money on demonstrations and testing. You lose money, but it's worth it in this case because we've earned the customer for life and we are building similar facilities at similar technology into their other facilities as well.
So what you're saying is a lot of these results were or are currently quantifiable.
Absolutely.
And you also talked about the pilot that was run for about a month, but also how long has it been in operation for?
Yeah, so I went just after startup because I'm trying to think. So it's been in operation about 3 years now, if not more, and running full time. This is one of those that there's no other options when you have emulsion. You got to run. There's no like, just put it into a bucket. This project is fantastic in that we are doing two things. We have concentrated that oil emulsion. We don't disappear the oil to something, we concentrate to a volume that's so small and so concentrated that someone can put into a burner. So, 20 to 30,000 gallons a day of water being turned into something like 3,000 gallons a week of concentrated oil. And it just gets removed as a small weekly dump and someone just puts it in a burner. It's that concentrated. So, So it's kind of an interesting way of getting rid of oil.
So from the results, 1 month pilot, Then it's been deployed in production in operation for the last 3 years.
Yeah.
So I assume the customer is happy?
Customer's happy. We are getting the second project undergoing with them. I credit to the facilities engineer at that site who said, I want to do this. It's different. It's easy for him to say, I'll just do what everyone else has done before. So he's a wonderful ambassador for a person whose main focus in life is not water, but looked at it and said, I think I want to do things better. So there's definitely credit there to the end user. He's not a fast follower, but an early adopter. It's very important. And then we have the performance of the system has been extremely, let's say, satisfying. It's performed. There's bumps in the road. Believe me, we lost one cross-flow pump. There's 2 cross-flow pumps, and there was this operational challenge, and we got this call saying this thing is not performing well. There's always those moments. We go out there, we solve the problem, it comes back on. We do some deep cleaning for a couple of days. We do some pump management, put some more sensors on to make sure when this happens again, it doesn't cause a problem. So, but this is the real bumps and knocks of a reuse plant. But as far as it goes, that's about the worst thing that happened, and it's running for 3 years. I'm pretty happy with it. Membranes are still in place, the exact same membranes.
So it's running for 3 years. You've got repeat business. It's all quantifiable. The numbers are there. These are all things that you're presenting in the paper at AMTA.
That's right.
That's pretty awesome. And so actually, what I'd like to do is conclude this podcast, and thank you for all of your insights. Of course, what we would like people who are listening to this, we invite you to listen in to some of the presentations that the CrossTek team is doing. This is actually one of them. This case study.
This case study is one of them.
And
it will expand to the reuse portion as well. I was focusing on the fantastic, front end of the process, but there's this sort of bioreactor and this 90% RO. Considering, like I said, lead to gold, the nastiest water you can ever imagine, becoming boiler feed water, which is kind of the highest quality of water you can feed into any equipment. So it's a lead to gold story, and it's pretty fascinating because there's actually years of data to share. And you can ask the presenter, please ask the presenter, our CEO, who is actually presenting a paper, because he was really instrumental in getting this up and running in the early stages. He's from that part of New York. He wanted to definitely have
that's right.
something,
He's from upstate New York.
Something for where he came from. So he was definitely on site as part of this. He was very excited about it, to be in like 20 minutes from his hometown where he grew up. And of course, he's a Red Sox fan now. I don't know if he's allowed back. But I think there's two other presentations from CrossTek. So we have 3 podium presentations. We're proud of it. We and they're all exciting, new stuff. That's what we do, and we have a poster as well. And I'm having the privilege of presenting a roundtable on ceramic membranes. So if you want to pick my brain about ceramic membranes, it's not much there, but come bring your own stuff to share, please, and I'll be happy to lead that session. It's also part of the show.
All right. Well, thank you very much, Stanton, and we will look forward to seeing people at the presentations that we have, and please stay tuned for our future podcasts.
Well, thanks, Dave. You did a great job in this, extracting useful information from me. That's unusual and difficult.
Thanks, Stan.
Thank you.